Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one more numerical question on round robin scheduling algorithm. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Consider the following process. Arrive at 0 units of time with given information. Process P1, process P2, process P3 and process P4 has arrived at 0 units of time and the order of arrival is also P1, P2, P3 and P4. And each process has its own burst time. Process P1 has 25 units of time, process P2 5 units of time, process P3 14 units of time, process P4 12 units of time. Now, a round robin scheduling algorithm with initial time quantum of 2 units. The round robin algorithm has no context switch overhead and time quantum of each process is double after every cycle. The completion time of process P3 is, they have given 4 options. We need to solve the question and find out what is the completion time of process P3. Now, whatever the questions we have solved related to the round robin scheduling algorithm, all are static time quantum only. But this question is related to the dynamic time quantum. What is the dynamic time quantum and how it works, I will discuss for you. Then I will solve this numerical question for you. Now we have a ready state and a running state. Let's consider that process P1, process P2, process P3 are there in the ready queue, okay, or ready state. Now the order of arrival is first P1, then P2, then P3. Now let's consider the time quantum is 2 units of time and process P1 has 6 units of burst time. Now process P1 will be scheduled to the running state, okay. Process P1, even it has 6 units of burst time, it will run for only 2 units of time. Once the 2 units of time is completed, its remaining burst time is 4 units and it will be scheduled back to the ready state, okay. So this one we will call it as a one cycle because process P1 has been scheduled from ready state to the running state and again it is preempted to the ready state. Is it clear? Now process P2 will be scheduled to the running state and it will run for 2 units of time. Again it will be preempted and sent to the ready state, okay. Then process P3 will be scheduled to the running state. It will also run for 2 units of time and again it will be preempted and sent to the ready state. Is it clear? Now all the process has completed one cycle. Now we need to run the process P1 again, okay. So process P1 will be scheduled to the running state. Now initial time quantum of process P1 is 2 units. As it is completed one cycle, what they said, time quantum of each process is doubled every cycle. So process P1 has completed one cycle. Now process P1 time quantum will be doubled. It will become 4 units of time. Now process P1 will run for 4 units of time and its burst time is 0 units, remaining burst time. So as its remaining burst time is 0 units, P1 has completed its task. It will go to the terminated state. Is it clear? So this is what the information they have provided. So with this knowledge, we will solve this numerical question. Okay. Now we will take the two queues. One is the ready queue and another one is the running queue, and then we will draw the Gantt chart. Okay. First one is we have a ready queue and then we have the running queue and then we will draw the Gantt chart. Always the Gantt chart will start from 0 units of time. Okay. Now process P1, process P2, process P3 and process P4 has arrived at 0 units of time and the order is P1, P2, P3, P4. Now process P1 has arrived first at 0 units of time. It will be dispatched to the running queue. So as the initial time quantum is 2 units of time, process P1 will run for 2 units of time and then it will send to the ready queue. Is it clear? So its remaining burst time is 23 units. Okay. So process P1 we have done once. It will be sent to the ready queue. So it has completed one cycle. Now process P2 will send to the running queue. It will also run for 2 units of time. Process P1 then process P2. At 4 units of time it completed its time quantum. Its remaining burst time is 3 units. So process P2 will be sent to the ready queue. Now process P3 will be dispatched to the running queue. It will run for 2 units of time. Okay, at 6 units of time, it has completed its time quantum. Its remaining burst time is 12 units. As there is a remaining burst time, we will send the process P3 to the ready queue. Then process P4 will be dispatched to the running queue. Okay, and it will run for 2 units of time. Its remaining burst time is 10 units. So we will send the process P4 back to the ready queue. Okay. Now process P1 will come to the running queue. Okay, is it clear? Now initial time quantum of process P1 is 2 units. Okay, now as it completed one clock cycle or one cycle, its time quantum will become 4 units. So now process P1 can run for 4 units of time. Okay, so at 12 units it will complete its time quantum and its remaining burst time will become 19 units. Okay, is it clear? So as it has the remaining burst time, process P1 will send back to the ready queue. Is it clear? Now process P2 will come to the running queue. Okay, as the process P2 also completed one cycle, its time quantum also will be doubled and it will become 4 units of time. Okay, is it clear? Now process P2 remaining burst time is 3 units, so it will run for 3 units. Okay, and it will go to the terminated state. So its remaining burst time is 0 units. So process P2 has completed its task. Okay, so as process P2 has completed its task, it will go to the terminated state instead of ready queue. Is it clear? So now process P3 will be scheduled to the running queue. Even process P3 has completed one cycle, so its time quantum also will be doubled and it will become 4 units of time. So now process P3 will also run for 4 units of time. At 19 units of time, its remaining burst time will be 8 units. Is it clear? Are you able to understand? As it has remaining burst time, it will be sent to the ready queue. Is it clear? Now process P4 will be scheduled to the running queue. Even process P4 has completed one cycle, its time quantum also will be doubled. It will become 4 units. Is it clear? Are you able to understand? So process P4 also will run for 4 units of time. At 23 units of time, its remaining burst time is 6 units. Okay, and it will be sent to the ready queue. Okay, now process P1 will schedule to the running queue. Now again it completed one cycle. So previous time quantum is 4 units. Now it will be doubled. It will become 8 units. So process P1 has to run for 8 units of time. Look at its remaining burst time 19 units. So it will run for 8 units. Okay, and its remaining burst time will be 11 units. Is it clear? Are you able to understand it or not? Previously it was 19. 19 minus 8 is 11. Okay, is it clear? So process P1 has its remaining burst time. It will go back to the ready queue. Is it clear? Now process P3 will be sent to the running queue. Now even process P3 has completed one more cycle. So its time quantum will be 8 units. So process P3 will be run for 8 units. Its remaining burst time is also 8 units. So at 39 units, it has completed its task and will go to the terminated state. So we will keep the remaining burst time is 0. So it has gone to the terminated state. So it will not go back to the ready queue. Okay. Now process P4 will be sent to the running queue. Okay. And process P4 also completed one more cycle. So its time quantum will become 8 units. Is it clear? Now process P4 needs only 6 units of time. Even its time quantum is 8 units, it needs only 6 units of CPU. So it will run up to 45 and it will complete its task. It will go to the terminated state. Okay. Now only process P1 is there in the running queue. Okay. Now its time quantum will be again doubled, so it will become 16 units. However, process P1 needs CPU 11 units of time, so process P1 will complete its task at 56 units of time. Is it clear? So at 56 units of time, all the process has completed their task. For your clarification, you can calculate the sum of all the burst time. 25 plus 5 is 30. 30 plus 14 is 44. 44 plus 12 is 56. So at 56 units, all the process has to complete their task. So our solution is correct. Now what they have asked, the completion time of process P3. At what time the process P3 has completed its task? Here at 39 units of time, process P3 has completed its task. So the right answer for this question is option B. I hope you have understood how I solve this question. If you still have any doubts related to this question or related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.